Dust might have snuffed out the dinosaurs. A simulation suggests that fine particles played a stronger role in cooling the planet and stalling photosynthesis after an asteroid impacted the Earth. On a spring day over 66 million years ago, an asteroid slammed into the sea just off the coast of modern-day Mexico. Known as the Chicxulub impact, it set off a global shockwave, earthquakes and megatsunamis that exterminated the non-avian dinosaurs and plunged Earth into a long and dark winter. A study published Monday in the journal Nature Geoscience has uncovered a cause of this cold snap: dust. The study's authors say that micrometer-size fine silicate dust lingered as long as 15 years in the atmosphere after the impact and contributed to the global cooling. Additionally, they say, all photosynthetic activity on Earth may have ceased completely within 2 weeks following the Chicxulub impact, largely because of fine dust. Stephen Brasat, a paleontologist at the University of Edinburgh who was not involved in the research, said studies like this one aided understanding of the time period after the asteroid's impact. They help us empathize with T-Rex, Triceratops and the other dinosaurs that woke up in the morning on the top of the food chain, but by the end of the day we're facing a world in chaos, he said. During fieldwork in 2017, Pim Casks, a geologist at Vrije Universiteit Brussels in Belgium and an author of the new research, collected some fine-grained samples from a geological formation in North Dakota known as Tanis, which yielded a treasure trove of fossils. While Tanis is 2,000 miles from the Chicxulub impact, seismic waves created a deposit of minerals known as the Cretaceous-Paleogene boundary. It is about 4 feet thick and corresponds to the event. He shared the samples with Sem Berksenel, a paleoclimate modeling researcher at the Royal Observatory of Belgium who was then a graduate student at Universiteit Libre de Bruxelles. One of the key questions we wondered was what was the primary governor of the Chicxulub mass extinction event, because in the literature, there have been diverse hypotheses addressing this phenomenon. Dr. Senel said, the role of dust has often been overlooked. Instead, scientists have focused on sulfur particles that rocks released after the asteroid vaporized them, as well as soot from the impact and subsequent wildfires. The effects of the dust were not well known, Dr. Casks said. Most of the work that has been done used very coarse-grained material that rains very rapidly out of the atmosphere or extremely fine particles that also rain down relatively quickly. The sulfur and soot, he said, were hypothesized to be better at absorbing and blocking sunlight compared with dust and thus the likely harbingers of the impact winter. According to Dr. Senel's computer simulations, which incorporated data from sulfur particles, soot and the measurements from Dr. Casks' samples, fine dust was a climate-heavy hitter. In the asteroid's aftermath, a cloud of fine dust thinner than a strand of hair clung to the atmosphere. Unlike sulfur and soot, which disappeared over time, these particles stayed put for at least 15 years. This led global average surface temperatures to plummet by as much as 27 degrees Fahrenheit. Global photosynthesis was interrupted within 2 weeks, Dr. Senel said. Because of fine dust, photosynthesis by land-dwelling plants was interrupted for 620 days after the impact. It took 4 years before the atmosphere cleared up, allowing plants to get enough sun to recover. Jan Smit, a paleontologist at Vrije Universiteit Amsterdam who was not involved in the study, said the findings about Earth's cooling after the asteroid are in the ballpark, but he said the idea that photosynthesis ceased for years, first proposed in the 1980s by Luis and Walter Alvarez, father and son scientists, was contentious. Neither their hypothesis nor the new research accounts for how marine plants survived, although it can explain how dormant seeds and flowering plants recovered. Incorporating fine dust measurements from more sites will be needed to make more global conclusions. Dr. Senel and Casks say the computer simulation does show a slight difference in climatic activity between the northern and southern hemispheres, but they acknowledge that more research needs to be done. That's something we would like to figure out to see if there are differences around the globe, maybe some regions that were less affected by the meteorite's impact and why some groups survived and others didn't. Dr. Casks said, I think this is just a starting point for some cool research and to find fossil evidence of this global response. The dinosaur age may have ended in springtime. A new study examining fossils of fish suggests animals were wiped out by a massive meteor at a time when they were just emerging from hibernation and having offspring. The dinosaur-killing meteor hit in spring. That is the conclusion of scientists who examined the bones of fish that died on that day when a 6-mile-wide asteroid collided with Earth. These fishes died in spring, said Melanie Doring, a graduate student at Uppsala University in Sweden and lead author of a paper published on Wednesday in the journal Nature. The reign of dinosaurs ended in spring. Scientists have known when the meteor hit, just over 66 million years ago, give or take 11,000 years, and where it hit off the Yucatan Peninsula of Mexico. That ended the Cretaceous period of Earth's geological history, but even though 3/4 or more of the species of plants and animals disappeared in the mass extinction that followed, it has been hard to pinpoint fossils of anything directly killed by the meteor. But in 2019, paleontologists published the discovery in southwestern North Dakota of what appeared to be a mass graveyard of creatures that died hours or days after the impact. Although North Dakota was about 2,000 miles from where the meteor hit, the seismic waves of what was the equivalent of an earthquake with a magnitude of 10 or 11 sloshed water out of the lakes and rivers and killed the fish. Tektites, small glass beads propelled into the air by the impact, rained from the skies. The researchers spent years exploring the site known as Tanis, which is in the fossil-rich Hell Creek Formation that stretches across 4 states. An article in The New Yorker described Tanis as a wonderland of fossil finds. The initial scientific paper describing the site was more sparse on details, focusing on the geological setting. With the new science results, the fossils now provide insight into the cataclysm that was previously impossible to discern. It's amazing that we can take an event, a single moment that happened 66 million years ago, literally a rock falling down and in an instant striking the earth, and we can pinpoint that event to a particular time of the year, said Stephen L. Brasat, a paleontologist at the University of Edinburgh who was not involved in the research. I think it's a detective story of the highest caliber. Animals in the northern hemisphere, some emerging from hibernation or giving birth to young, might have been more vulnerable to extinction. If it was spring, then it was not very likely for many organisms to be in hibernation, Ms. Doring said during a telephone news conference arranged by Nature. Animals in the southern hemisphere, hunkering down in autumn, might have been more sheltered from the sudden, drastic change in climate. If you could hibernate, that would increase your chances, Ms. Doring said. If you could seal yourself off in a burrow or if you could shelter underwater, that could help you. Dr. Brasat agreed. I think there is some potential here for helping understand the patterns and the processes of the extinction, he said. Ms. Doring first heard about Tanis during a talk in 2017 by Jan Smit, an expert on the dinosaur extinction at Vrije University in Amsterdam, where she was working on a master's degree. She was intrigued by his description of the North Dakota fossil finds. I actually started typing him in a mail from my phone from the back of the room, saying, "Hey, if you have these fishes, can we please do isotopic analysis on their bones?" Ms. Doring said. She got in touch with Robert D. Palma, the paleontologist orchestrating the study of Tanis. In August 2017, Ms. Doring flew to North Dakota and spent 10 days at Tanis excavating fossils of 6 fish, 3 sturgeon and 3 paddlefish. In the laboratory, the scientists sliced thin pieces of bone from the lower jaws of the paddlefish and from the pectoral fin spines of the sturgeon. They saw repeating light and dark lines reflecting seasonal changes in the rate of growth, similar to tree rings. The outermost part of the bones indicated that the fish were becoming more active and growing faster after the end of winter. My guess is on April, Ms. Doring said. It was definitely not summer. Swings in the levels of different types or isotopes of carbon in the bones indicated how much plankton was in the water for the fish to eat. The levels were lower than what they would be during summer's peak abundance. That added to the various lines of evidence that we have that these fish perished in spring, said Jeroen van der Lubbe, a paleoclimatologist at Vrije University and one of the authors of the Nature paper. Tektites were found trapped in the gills of the fish but not in the digestive tract. They couldn't swim on Ms. During said. They immediately died. Another team of scientists led by Mr. De Palma independently performed similar analysis on fish fossils and reported almost the same conclusions last December in the journal Scientific Reports. The Chicxulub impact is thought to have triggered a global winter at the Cretaceous Paleogene (KPG) boundary 66 million years ago. Yet the Cle.